talk about robots and robotics and how they are building and working. The word robot comes from Karel Capek's Rossum's Universal Robots book. In this book, robots are defined as emotionless, mechanical, autonomous machines. Nowadays, emotionless adjective lose that meaning about robots with the artificial intelligence. If we look at a dictionary, we will see a definition: a machine that can perform a complicated series of tasks by itself. Robots may perform these tasks in different ways. We could group levels of autonomy in 3 levels. My friend Bilge will explain this topic in more detail at the topic of autonomous cars. In base level, robots are operated by humans. At mid-level, robots take commands by human and perform tasks autonomously. At top level, robots both decide and operate autonomously. Different robots help our lives in different ways. For example, bomb defusal bots are saving most soldiers' lives. On the other hand, surgeons could use surgical robotic arms and 5G communication to operate surgeries miles and miles away. Asimov is a sci-fi novel writer, and he created 3 rules about save humanity and robots. First one, a robot may not injure a human being or through inaction allow to be in harm a human being to come harm. Second one, a robot must obey the orders given it by human being except where such orders would conflict with the first law. Third and the last one is a robot must protect its own existence as long as such protection doesn't conflict with the first or second law. Today, we will talk mostly about how they are building and working. I'll make an introduction to these 2 topics, and my friend will give more details in their speech. Building a robot in the base has 3 different parts: mechanical, electronical, and control system. Mechanical systems are like the musculoskeletal system of the human body. Mechanical systems doing tests by it getting commands by the control systems and electrical systems. While building a mechanical system, designer consider the project's requirement about size, force, and toughness. I'll give a few examples about robotic arms. For example, different robotic arms need motor forces. Surgical robotic arms need more precision than force, while car assembly arms need more force. Electrical systems are like the nervous system of the human body. They are creating, communicating, and processing electrical signals. They are communicating electrical signals between part of the robots, and they are including some sensors to understand environmental conditions like distance, color and contrast, or humidity, and to understand self-states like temperature, torque, and battery level to defend itself. They are delivering electrical signals to the microchips for the process to take responses. Responses are dependent on their codes. Codes are making decisions with the default situation and environmental conditions. These decision models are specified in Asimov's rules. In the codes, each robot has different algorithms, different coding languages. I'm going now my friend Baran going to talk about a different topic, consumer robotics.
Altug. We will talk about consumer robotics now. So, what consumer robotics are? And consumer robots are the robots you can buy and use just for fun or to help you with tasks and chores. Examples are the robot dog Aibo, the Roomba vacuum, AI-powered robot assistants, and a growing variety of robotic toys and kits. But today, me and Umut will talk about competitive robots and domestic robots in consumer robotics. And now let's begin with competition robots. Competition robots are the robots which the students can improve their engineering skills by creating new technologies from them. And there are so many genres in robotic competitions, and we can specify several different robotic competitions, but including robocross, garbage collectors, and autonomous unmanned aerial vehicles, etc. But the most popular robots are line-following robots, sumo robots, and maze-solver robots. And you can see that there is a distance sensor and photoelectric sensor they are used in these 3 robots. Now I'm going to introduce you these 3 types of competition robots. The first one is line follower robots. The aim of the line following robot is to complete track in the fastest way by using the black line autonomously after being released on the track. Thanks to contrast sensors, the engine is powered depending on whether the bottom of the robot is black or white, and the tracks are designed to be black lines, so the engine must be adjusted to move on the black line. And there is a specific calculation, feedback calculation, PID calculation, used in autonomous machines is very important by for line following robots. It consists from three parts, which they are proportional, integral, and derivative, and you can see the necessary calculations over here. For the optimum speed and accuracy, we change the coefficients that occurs in PID with coding Arduino-based software. Now let's talk about sumo robots. Sumo robots capable of autonomous movement containing electronic circuits designed to fight each other, programmed for intended movement. They are produced in different standards and categories. Sumo robots meet each other on a round ring that's called dohyo. And during the match, sumo robots try to throw each other out of the dohyo. Unlike the line followers, sumo robots also have distance sensors detect their opponent. And obviously, to compete in this area, you need a powerful engine and wheels with friction to keep it on the dohyo. And finally is maze solver robots. And I'll make shortly. Maze solving robots, as you can understand, their purpose is to solve the maze in the fastest way by using distance sensors all around them and specific software algorithm. Now, and you can see the Arduino code over there. Arduino schematic. And now Umut will talk about domestic robots.
Thank you, Baran. Domestic robots help us at home to make housework easier and faster. One of them is cleaning robot. Cleaning robots are a subtype of mobile robot. Mobile robot is a robot that is capable of moving in surrounding. There are three mental models of how a mobile robot operate. In first is hierarchical. In this part, robot scans and analyzes the environment where it plays. Then the robot plans and takes action. Second one is reactive part. In this part, robot acts or reacts according to the information it receives from environment. Last part is hybrid. Robot reacts according to the combination of these two behaviors. Also, cleaning robots act with this logic. Then how cleaning robots work. There is a microchip like Arduino Nano card inside cleaning robots. Inside this microchip, we have a circuit to help us communicate with computer. One regulator circuit that keeps output voltage constant for increasing efficiency. And one oscillator circuit that adjusts the operating frequency of the microcontroller. Then we have one power unit and sensor. Sensors commonly used in cleaning robots for distance measurement. These are vibration ultrasonic light sensors. And this is the photo of a low noise op-amp for small signal. Lastly, we have brush and vacuum cleaning module. In this module, we have two DC electric motors. One motor controls the vacuum fan, while other controls the rotation of the electric purse. And this is how cleaning robots work. Let's move on to the next topic, commercial robots. Many people think about robots mostly in industry area. However, with technological advancements have led to increasing utilization of commercial robots. And there are field robots, medical robots, drones, service robots, and etc. in commercial robot area. Today, I will talk about medical robots and drones. In medical, we use robotic arms more than other type of robots. The medical fields that we use robotic arms are neurology, orthopedy, general laparoscopy, prosthetics and exoskeletons, rehabilitation, and etc. Now, let's look at how robotic arm work. Firstly, in A part, we have IHOTUS interface. It's a type of controller. It can change according to the system. Then we have DAQ. We use DAQ for adjust and operate the physical abilities like temperature, current, voltage, pressure, weight, etc. And also, coding part is in DAQ. For the coding part, you can use C or C++. But LabVIEW is the most recommended coding app because you can make changes easily and it is easy to read. In B part, we have robotic arm. Then in C, D, E parts are controlled by DAQ. Also, I want to give some examples about robotic arms that we use in medical area. First one is Zeus. Zeus was made by Computer Motion Group. Zeus has 3 robotic arms, as you can see here. One of them is for camera that allows the surgeon to see inside of the patient. And surgeon activates this camera with his voice. Other 2 are for cutting, holding, and etc. Next one is Davinci Robotic Arm. Davinci was made by Intuitive Surgical Group. Davinci has 4 arms. One of them is for tree monitoring. And surgeon operates the hands on the other 3 arms by inserting his or her fingers into ring and using foot controls like pedaling cars. Robotic arms used to control instruments instead of direct manipulation by surgeon's hand. With this system, arms remain steady all the time, and it eliminates the shaking of human hands electrically. Davinci has 7 degrees of freedom, and also it has a simulation that teaches how to use the console. And lastly, Amadeus. It was made by Titan Group. Amadeus is almost same as Davinci, but they have some difference. Like Amadeus uses snake-like multi-articulating, means like joint, arms, and its system designed to make teleoperations easy for long-distance surgery. And let's move on to the other topic, drones. Drones is an aircraft without a human pilot, and its system is a system for communication between controller and vehicle. So, how drones work? I will explain this over quadcopter layout for better understanding. Quadcopter is a type of drone with 4 propellers. Quadcopter has 4 motors, and these motors are positioned under propeller, and it controls propeller's rotation and speed. Then we have speed controller for each motor. Speed controller controls the speed and adjustment of the motors. Also, speed controllers are connected to motors with 3 wires that called phase wires. Red one for positive, black one for negative, and yellow one for signal. And then we have a battery. It is actually a lithium polymer battery because it is light, small, and it contains a lot of power. Of course, it can change according to the drone we use. Next one is drone's brain. It is flight controller. It is inside autopilot in here. It has tons of different sensors that allows for flight control algorithm and flight stabilization. And if you want to put cam or video transmitter, you need to connect them with a flight controller, because flight controller has special ports for them. Then we move receiver. We need to connect the receiver with an antenna to a remote control transmitter to control drone. Then we have gimbal here. It is for keeping camera at the same angle with drone, regardless of the movement of drone. Lastly, GPS model. It is for making things easier for long distance drive. Now, Baran will talk about industrial robots.
Thank you, Umut. Industrial robots are fully autonomous robots that are used to increase efficiency and speed in jobs that help physical tests people find difficult to do. As you all know, although many robots are used in this area, the most common robots are industrial robotic arms. These robotic arms used in fully autonomous factories perform their tasks synchronously in the factory. Now I want to give you information about usage areas of robotic arms. And the first one is speed. Particularly when choosing robotic arms for picking and placement applications, it is important to pay attention to manufacturer ratings for speed. Changes and upgrades to speed ratings can be achieved in some types of robotic arm through chains made to the choice of belts, motors, or actuators used. The second one is load. All types of robotic arms have a given load capacity. Different sorts of robot arms are supported by different design frameworks, which can increase or decrease overall load capacity. This must be balanced with consideration of physical placement and footprint. And I choose just 2 of them because I think they are the most important ones. And now let's move. How many types of robotic arms are there? The first one is Cartesian robotic arms. In robotic arms terms, mechatronic Cartesian or gantry robot tends to consist of 3 articulating joints that are programmed using these 3 X, Y, and Z coordinates, moving linearly along these 3 axes, and they can be mounted horizontally, vertically, or overhead, and they are widely used in a range of applications, such as machining parts or picking and placement alongside conveyor belts. And you can see the joints and the axis. The second one is cylindrical robotic arm. And cylindrical robotic arms, in contrast to Cartesian version, are ones whose axes form a cylindrical coordinate system. In short, their programmed movements take place within a cylindrical shaped space, up and down, and rotational movements. And they are using areas of spot welding and machine tool handling, where the rotary and the prismatic joints give it both rotational and linear motion. And you can see the working logic over there. And lastly, polar and spherical robotic arms. Again, just like cylindrical arms described before, a polar or spherical robot is one that operates within a special spherical or potential locus of movement. This is achieved through a combined rotational joint, two rotary joints, and a linear joint. The polar robotic arm is connected its base via a twisting joint and the subsequent spherical workspace. It has access to make it useful for performing similar roles as cylindrical robotic arms. From now on, BG will keep going with autonomous cars.
Hi guys, now I'm going to talk about autonomous vehicles and its details. The first thing I want to explain is what an autonomous vehicle is. An autonomous car, also known as self-driving car, is a vehicle capable of sensing its environment and operating without human involvement. A human is not required to take control of the vehicle at any time. An autonomous car can go anywhere a traditional car goes and do everything that an experienced human driver does, but of course under certain conditions. Here, the Society of Automotive Engineers currently defines 6 levels of autonomy, from fully manual to fully autonomous. When we look at this table, it is seen that as the level increases, the control of the vehicle passes from human to automation. Now let's look at the details. In level 0, which is no automation, the driver completely controls the vehicle at all times. Driver monitors the road, decides when to speed up or brake, monitors surroundings, so there is no automation. In level 1, the vehicle features a single automated system, monitors the speed through cruise control, automatic brakes, and lane assist. In level 2, at least 2 controls can be automated in unison, such as adaptive cruise control in combination with lane keeping. By the way, adaptive cruise control is an intelligent form of cruise control which slows down and speeds up automatically to keep pace with the car in front of you. Here, the human still monitors all the tasks and can take the control at any time. Up to this part, the human monitors the driving environment. After these levels, the automated system monitors the driving environment. In level 3, which is conditional automation, the car can manage all safety critical functions under certain conditions, but the driver is expected to take over when alerted. Also, automation has environmental detection capabilities, but human override is still required. In level 4, which is high automation, the vehicle performs all safety critical functions for the entire trip to decide and apply under certain conditions. The driver is not expected to control the vehicle, but human override is still an option under some situations. And lastly, full automation. The vehicle includes human only as passengers, so there is no human interaction and human attention. The car is completely capable of self-driving in every situation. Currently, there are no legally operating fully autonomous vehicles in our life. There are, however, partially autonomous vehicles, such as cars and trucks, with varying amounts of self-automation, from conventional cars with brake and lane assistance to highly independent self-driving prototypes. I have talked about levels up to this part, so how do these cars work? What kind of technologies do they have? Autonomous cars rely on sensors, actuators, complex algorithms, machine learning systems, and powerful processors to execute software. When we look at the technology part, we encounter very complex and interconnected system here. Self-driving cars include significant amount of technology in them. The hardware inside these cars has stayed consistent, but the software behind the car is constantly changing and being updated. Fully autonomous cars are still undergoing testing in several parts of the world, but none are yet available to the general public. So these are some primary technologies. I have 5 of them. In hardware parts, we have radar, LiDAR, camera vision systems, complementary sensors, and connectivity. Radar detects and tracks the presence, direction, and speed of objects using radio waves. LiDAR is an extremely accurate depth perception information to the car by shooting lasers and receiving reflection data to create 3D models of surrounding objects. Computer camera vision systems, high resolution and detail to recognize surroundings most accurately. Cameras are best for training machine learning models, but they are not ideal for calculating depth perception. Complementary sensors are like microphones enabled to the car to pick up audio, such as emergency sirens. And lastly, connectivity. External source of the truth aids self-driving cars with maps, construction, traffic, weather conditions, and adjacent cars. Now, the software part. Here, in this part, we have a bunch of algorithms, but I have 4 of them. Regression algorithm is used for detection and localization and predicting movement. Decision-making algorithm is used for decision-making. It uses multiple models to help recognize and make appropriate decisions. Pattern recognition algorithm is used for object recognition, and it helps reduce the data set by finding patterns and commonalities. And lastly, clustering algorithm is also used for object recognition, and it uses structures in data to organize data into groups-based commonality. Now, let's look at how all these stuff work when combined. Here, we have computer vision. The vision system is the eyes of the car. This picture shows how car sees its surroundings and how it identifies the object. Sensor fusion is the process in combining information from other sources. This picture is generated from a Google self-driving test vehicle's LiDAR sensor. Localization, the car uses numerous vision sensors combined with reading from high-tech GPSs to figure out where the car is exactly in the road. Then path planning. This system takes all the information about our surroundings and making a decision about which way we need to go to get our destination. And lastly, control. The process of physically moving the car according to the decisions made in path planning by constantly adjusting the steering, accelerate and decelerate. Based on the path planned in the previous steps, the car has concluded the set of waypoints and it will follow in its journey to the desired destination. Now, let's look at the useful and harmful effects of autonomous vehicles for us. From now on, Altug will continue.
Thank you, Bilge and my friends. Now I'm going to talk about his pros and cons of autonomous cars and self-driving. Different segments of society have different arguments to legalize it or inhibit it. Traditionalist negative arguments are risk of damaging people. They defend the idea that the morality of autonomous car is a big problem for them. All we know is the trolley dilemma. We have to decide what an autonomous car has to do in a similar dilemma. After a possible incident, the judge's decision is an open question. Who is the guilty? Programmer of autonomy, driver who trusted the autonomy. You can share your opinion in chat. On the other hand, every software could be hackable. A black hat hacker group could easily hack all cars in traffic and they could use that for their goals. Fast and Furious fan can remember a similar scene. In this scene, a hacker group attacking a politician via the cars on the road. That's enough. There is not only bad parts. Reformists positive arguments are interested in the ability of the robot. They can work 24/7 with the same motivation. They make fewer mistakes than humans and they can learn to drive better. In this clip, a Tesla avoiding from a crash with the calculating and computing the possibility of coming crash. With the cloud communication to every other car in the ecosystem on the road, this communication helps each car get information about environmental conditions. In this photo, we could see a foggy condition. Every car on the road could drive like train on the rail. And the last point I will talk about is autonomous vehicle companies. Autonomous vehicle companies are mostly in USA-based startups. Different companies have different approaches on autonomy. Tesla is a company that builds the most popular electrical cars in the 21st century. Tesla has 3 different autopilot substructures in time. First one, Mobileye, appeared in 2014 and was used for just 2 years. Mobileye is an Israeli company cooperating with Intel. Mobileye develops vision-based self-driving cars and ADAS. Since 2016, Tesla changed the substructure between 16 and 19. Tesla transferred from Intel to NVIDIA supercomputers, and Tesla is not just the automotive company that uses autonomous car systems from other companies. They became a company builds autonomous car systems. After Tesla, I could say Uber for their driver-free taxi plans. Uber is not a car builder, but they are setting up systems on the cars for using that as taxis in future. Google with the Waymo company also in this sector. We couldn't forget traditional car companies. With the trials of EV cars, Toyota with the Lexus, Daimler with Mercedes, and GM with the several companies, and a few more companies have some drives with autonomous cars. Test companies quality measures with covered distance. If a test car could run miles and miles without any accident, AI both learn roads and people's activities. Waymo, GM, and Tesla are the top-level runners.